Duraline's unique construction allows kinks to disappear quickly when the hose is pressurized, improves water flow performance, reduces risk of water loss to the branchman, minimizes the risk of induction problems when foam is being used, and ensures that maximum flow is always achieved. Duraline provides more water where and when it matters most, giving you added safety and security. This, coupled with its superior resistance to chemicals, ozone, UV and heat, makes Duraline the most cost-effective hose available. Remember, if it isn't Angus, it can't be Duraline.
Angus Fire continues to lead innovation in the technology of firefighting foams. With the introduction of Alcoseal 3x3 film-forming fluoroprotein, the user at last has a 3% foam that gives rapid knockdown and true security on hydrocarbons, excellent performance on polar solvents, MTBE and lead-free gasolines, suitability for non-aspirated, low expansion, medium expansion and subsurface foam systems. Excellent storage stability in all climates, plus minimal environmental impact. Alcoseal 3x3, the best 3x3 by far.
A warm welcome for passengers arriving at Gatwick this afternoon. Planes queuing up for takeoff had an even closer view. The airport was testing the latest firefighting foam on a simulated engine blaze. Manufacturers explained why this type of fire is so difficult to extinguish.
You've got fuel under pressure which is being vaporized and atomized at the same time, and that is when you get a cloud of fuel which gives you a very spectacular fire that you've just seen.
The new product tackles a key area in aviation fires.
One of the biggest problems in aircraft crash fires is that when the fire's been extinguished, pieces of fuselage, for example, can actually reignite the fire, and it can burn back suddenly, unexpectedly.
The foam eats up the fire and stops that happening. It's also less damaging to the environment than synthetic-based products.
In the field of aviation, the efficient protection of aircraft during maintenance and refurbishment is increasingly being achieved with water-powered automatic oscillating monitors like the OM1. This delivers a low-expansion foam blanket under the wings of the aircraft. Additional high-level monitors can also be used for fuselage and over-wing protection. These monitors are also widely used in the protection of helidecks on offshore platforms. Monitor systems are also required for marine applications, and Angus Fire has a comprehensive range focused on reliability for extreme environments. This includes the Angus RCM2 remote control monitor with aspirating foam cannon.
Successful application of foam to major tank fires requires portable monitors which throw an effective foam stream long distances. Angus Fire has addressed these criteria by examining the flow rate, foam quality and logistics needed to give this high performance requirement. In producing the Titan system, Angus Fire offers exceptional throw whilst maintaining a good quality foam blanket, yet ensuring simplicity of setup and operation. The Titan system, at last, a credible solution to portable foam attack.
Is believing, then take a look at what happens when the awesome power of Colossus combined with FP70 is unleashed on a massive 400 square metre fire, one of the largest test fires ever undertaken anywhere in the world. Incredibly, the fire is brought under control in only 45 seconds and is fully extinguished in only 80 seconds. Proof that Mega Colossus has what it takes to quench even the fiercest of fires.
Top pouring systems are also an acceptable means of protecting these fixed cone roof tanks, delivering the foam gently onto the fuel from above. But they do have to be tough enough to withstand intense heat while the system is being activated. Angus have pioneered a rugged design of top pourer set with a unique deflector plate for maximum effectiveness. This produces a butterfly pattern of foam which is thrown back onto the sides of the tank for gentle application across the fuel surface. Particularly important on polar solvent fuel. High back pressure generators are used for base injection systems protecting hydrocarbon cone roof tanks. Provided that a quality fluoroprotein or film-forming fluoroprotein foam is chosen for this application, rapid control and extinction can be achieved with minimal use of foam and water resources. In many cases, fires start or escalate in the surrounding bund or diked area. Portable attack can place unnecessary risks on firefighters' safety. The use of medium expansion pourers around the edge of the bund significantly reduces this danger. Angus MEX bund pourers provide gentle application of a fluid foam across large areas to give fast and effective coverage. These are ideal for cohesive natural protein-based foam like FP70 or Alkoseal. For example, this system, protecting polar solvent tanks, achieved full coverage in less than 2 minutes. The bulky yet fluid nature of the medium expansion foam enables pipes and flanges to be covered and kept cool, avoiding the danger of escalation. Even under severe wind conditions, gusting up to 50 miles per hour, FP70 foam still adequately covers the floor of large bund area. Liquefied natural gas or LNG storage tanks present a more difficult bund hazard. High expansion foam like Expandol has been shown to be the most effective means of protecting accidental spillages of such cryogenic liquids. LNG fires are extremely hot and require foam equipment capable of resisting this intense heat. High expansion foam systems are also widely used as a replacement for halon systems in the marine industry. The large volumes of foam bubbles provide rapid and effective filling of the engine room space, while also purging the area of potentially toxic smoke. Some installations have used halon systems to protect this seal area, but these are now being phased out under the Montreal Protocol. Angus Fire has pioneered the development of a foam replacement system called floater foam, which rapidly detects a fire in the seal area, then provides an initial burst of foam to control and extinguish the seal fire. On open-top floating roof tanks, the area of fire risk is initially small, starting in the seal area surrounding the floating pontoon. If no action is taken, it can spread to cover the whole surface area, proving extremely difficult to extinguish. Fixed systems are designed to deliver foam into this seal area swiftly before the fire has a chance to escalate. Such systems can extinguish a fire in its early stages. The burn mark on the outside of this tank shows where the fire started in the seal area. Without such systems, it's quite possible that the whole tank could become involved. Delivering foam into this area without wind blowing it away is a major challenge. Angus Fire has overcome this problem by developing its specialized rim seal pourer, which produces good quality fluid foam. This slides down the tank wall into the seal area, spreading out and rapidly providing total coverage. This is particularly difficult to achieve when the roof is at its lowest and most vulnerable position. In strong winds like these, the exceptional performance of the Angus rim seal unit still achieves a uniform foam blanket in the seal area.
for collecting high vol. A wide choice of models are available to suit different operational preferences and budgets. From Fetch 100 for local fire services using 5 and 6-inch high vol, through Fetch 150 for oil refinery fire services, right up to Fetch 200 for deploying and retrieving 8 to 12-inch high vol.
Specialist designers in our Contract Engineering Services department are able to engineer customized solutions under efficient project management. This ensures equipment delivery and commissioning is on time, and the overall project is completed within budget. Angus engineers can then guarantee satisfactory operation of the system. We do also offer a competitive service and maintenance contract, so the Angus fire system is regularly checked to ensure optimum performance and that it continues to meet the original design specifications during operation. Our particular expertise lies in special risk situations involving storage of hazardous liquids. Examples are oil refineries, petrochemical plants and LNG installations, process areas, transportation and marine terminal protection.